This is the homework helper for Chapter 5, Section 1 in the 8th grade textbook entitled Ratios and Proportions. Okay, so let's go ahead and start looking at the questions here. In 1 through 9, as you can see, those questions all have the same direction, and they are to find two ratios that are equivalent to the given ratio. Remember, ratios feel like, act like, function like fractions. So if we know how to write equivalent fractions, we can find equivalent ratios, no problem. All we have to do is either A, reduce the ratio down to simplest terms, dividing out the greatest common factor, or we can take any ratio and make it bigger by multiplying the top and the bottom, what we would normally call the numerator and denominator, by whatever amount we want, as long as it's the same amount. So for instance, in number 1 here with 9/12, that would be, if we're calling it a fraction, something that reduces by taking 3 out of both the numerator and the denominator. So that's what I'm going to do. I'm going to do 9 divided by 3, which is 3, and 12 divided by 3, which is 4. And there's one answer. And then let's say instead of thinking about making it smaller, I want to make it bigger. Well, let's say I want to do something kind of easy and multiply the top and the bottom by 2. 9 times 2 is 18. 12 times 2 is 24. So I have 18/24. And there are two ratios that are equivalent to 9/12. Pretty easy. All right, in number 2 with 4/20, again, we can reduce there. So we could chop 2 out of both the numerator and the denominator there. And when I do 4 divided by 2, that's 2. And 20 divided by 2, that's 10. Now notice what I did not do is I didn't actually take out the biggest number I could. The biggest number I could take out there is actually 4. So an option here is to come up with two smaller ratios, two smaller fractions. Remember, they're not really fractions, but they feel like, function like, act like fractions. 4 divided by 4 is 1. 20 divided by 4 is 5. Okay? And then in number 3, we'll do the same thing. Let's go ahead and take out a 5 out of this guy, because I see the greatest common factor of 15 and 25 is 5. Well, 15 divided by 5 is going to give me 3, and 25 divided by 5 is going to give me 5. And can't make anything else smaller, but I can make something bigger. Now, if you remember earlier, we multiplied by 2. In this one, I'm going to multiply by 10. And the reason I'm going to do 10 is because 10 is really actually a lot easier than 2, because all it's going to do is, unless there's a decimal there, which would scoop the decimal then, multiplying by 10 really just adds a 0. So this is going to be 150 over 250, and that's also equivalent to 15 over 25. And as you can see, in 4 through 9, you're going to do the exact same thing. You're just going to keep on coming up with something bigger or smaller, two ratios for each question. All right, let's go ahead and go down to the bottom part there, 10 through 17. Tell whether the ratios form a proportion. All right, so there's a couple ways you can approach these questions. If you see numbers that easily go into each other in terms of division or something I can easily multiply by to check, that is one approach. For instance, let's say we had a half and 2/5, which we know doesn't work, but I can use it as an example. To go from 1 to 2, we'd be multiplying by 2. So all I have to do is go check the bottom and see if multiplying by 2 works the same way there as well. If it does, it's a proportion. If not, it's not a proportion. Well, obviously 2 times 2 is 4, not 5. It didn't work, so that would not be a proportion. That's one option. Second option, we could change them both into something very simple, and by that I mean decimals. You can do the same thing just like they were fractions, make them decimals, and see if they are the same thing. So with this example I just used, I would do 1 divided by 2, which is 0.5, and I would do 2 divided by 5, which is 0.4, and I would see that those actually do not work out to be the same thing. So once again, we don't have a proportion there. All right, third technique there would be the technique of cross multiplication. Cross multiplication always works for us to check a proportion. What you're implying there is you're going to multiply the numerator on one side with the denominator on the other side, and do the same for the other multiplication that would exist. And if you get the same result, in that case, then you would have a proportion. If not, you would not have a proportion. So what you're going to do here is you're going to do 13 times 48 and check your answer. And you're going to do 16 times 39 and check your answer. And if they are the same thing, you have a proportion. Well, 13 times 48, that's going to give me 624, where 16 times 39 gives me 624. So in this case, yes, because we got a 624 when we did each diagonal, this is a proportion. Other option you have here, if you want, you can reduce the fractions that they're really ratios, but again, they function just like fractions, so we'll call them fractions. You could reduce the fractions or make them bigger, really, and see if somehow you can make equivalent fractions. We could try that on number 11. With 21 49ths, we could chop a 7 out of 21 and 49 and come up with 3 7ths. And in 2856, well, luckily for us, we could actually take the exact same thing out there, take a 7 out, and when I do that, that's going to give me, in this case, 4/8, which of course goes all the way down to a half. And so we'd be saying our half and 3 7ths equivalent. And most of us know that half and 3 7ths are not equivalent, so that's going to be a no. It does not matter to me which technique you use. You can do anything you want to check these. I think some of you would probably find changing these into decimals to be really quick, because we know we're just going to do top divided by bottom, top divided by bottom. Either the numbers are the same or the numbers are not the same. That's going to work every time. Or you can do the cross multiplication. I really like the cross multiplication because where they're going to be heading here is they're actually going to have us solving proportions when they throw a variable at us, which is really more solving equations. So you're going to end up doing it anyway pretty soon. So on number 12, we're going to do 12 times 42 on the one diagonal, which is 504. And on the other diagonal, 18 and 28. Well, 18 times 28, that's going to give me 504 as well. So since those diagonals both spit out 504, this one is a yes. Those are a proportion. Those two fractions are equal to each other. And at number 13, which will be the last one I'll touch with you, you can do 14 through 17 on your own. These are really simple fractions to work with. I think you are looking at 18/27 and saying, take 9 out, take 9 out, take 9 out. Yeah, let's take 9 out. Chopping 9 out of 18 is 2. 9 out of 27 is 3. With 10/15, we chop 5 out of each of those guys. 10 divided by 5 is 2. 15 divided by 5 is 3. 2/3, 2/3, since the fractions are the same, that's another yes. All right, let's finish this up by taking a look at a story problem down here. Number 19, in a survey, 9 out of 10 doctors recommended a certain medicine. If 80 doctors were surveyed, how many doctors recommended the medicine? So what they're saying here is 9 out of 10, or the fraction 9 over 10, shows how many recommended the medicine. 9 recommended out of 10 total doctors. They're saying that they're going to go test this out with 80 total doctors. And they want to know how many are going to recommend it. So notice when I'm writing this fraction on the right side, setting up my proportion here, remember, proportion is just two fractions set equal to each other. Where am I putting the 80 total doctors? Well, notice that I have the total number on the bottom, so I've got to put the 80 total number on the bottom as well. And in the top, I've got how many we're recommending. Well, we don't know how many are recommended, but that's always got to be in the top because I wrote it in the top over here. So I'm going to put x right there, and then I'm going to cross multiply to solve. So I've got 10 times x on the one diagonal, 10x. And 9 times 80 on the other diagonal, there's 720. And, well, we're already solving proportions, really. Divide out the 10 to solve that guy, and you get 72. Now, if you're not seeing how we came up with that, let me make this a little bit simpler. Look at what we have on the bottom here, 10 to 80. 10 to 80 means we're multiplying by 8. So I have to do the same thing on the top, and I know I have to do the exact same thing because that's the only way it's a proportion, is if I do that exact same thing. So I say, okay, I'm going to multiply by 8 in the same way on the top. Well, 9 times 8 is, no surprise to you, 72. So 72 doctors, no matter which way we put this together, recommended the medicine.